Okay, so I had a little interruption there, but we're back. Now, to get an idea of thinking about when a binding occurs, what I thought I'd do is give you a sample piece of code. And let's assume that you see something like this. You have a piece of code in a method. All right, so int count, and then we say count equals count plus 5. All right, so the question that we have is maybe it shouldn't be when does the binding occur, but a better thing to say is when do the bindings, plural, occur? Because there's different kinds of bindings that are going to occur, right? We have the sextuple of name, address, value, type, lifetime, and scope. And what we want to be thinking of is when do those various things get bound to the variable count? And a good question to ask for you guys is, watching this, is can you come up with some specific points in time from the moment the user finishes writing the code to when the code is actually executed? Are there specific binding times that you can come up with? So if you're still not sure what I'm saying, like, I'll give you a good example. Like a binding time might be at runtime. So when the code's being executed, that's when one of the 6 attributes, name, address, value, type, lifetime, and scope, that's when that attribute is bound to the variable. So take a moment and see if you can come up with a list of these binding times. So hit pause and think about it. Hit pause. All right, I'm assuming you're back after hitting pause. Thought about it a little bit, and maybe you've come up with a couple times. So I'm going to give you a list. I'll put the list down here. So one point in time where the binding time might take place is at language design time. Another time might be at compile time. Another time might be at link time. Another time might be at load time. And final time is runtime. So these are the possible times that you might have. All right, and let's take a look at count. All right. So when would you say that? And I'm just gonna list them here and see if we can get them all locked down. So we've got name, the address, the value, the type, lifetime, and scope. All right. So the name of count, okay, that is going to be determined not at language design time. That doesn't make any sense. But before we do anything to execute the program, we are going to know what the name of count is. So we're going to say that that's at compile time. All right. The address or memory location of count, well, that is going to be the true address, like the actual address in memory for count is going to be at well, that's sort of interesting to think about. Um, in Java, the answer is everything in Java is a method, and methods are executed at runtime. So the address for count is going to be at runtime, right? Count is going to pop up on the stack. That's the way local variables work in methods. So it's going to pop up on the stack, on the local stack, and so its location is going to be determined at runtime. Likewise, the value of count is going to be determined at runtime. Probably makes sense to say here count equals 0 to initialize it. All right, the type of count, that is going to be determined at compile time. The lifetime for which count exists is going to be something that's determined at well, that's kind of interesting too. Like, how long is count going to stay around? That's something that's going to be determined at runtime. And the scope of count, in other words, what pieces of code are allowed to access or look at count, is something that's going to be determined at compile time. So there's not a lot going on here other than compile and runtime. But for some languages, the link and loading and language design become important as well. I mean, I might say that certainly for the value for count, the language design time is going to determine the range of values that are associated with count. And also, if we're talking about addresses and the memory cell, language design time is going to determine how much space in memory count occupies. All right. So there's an interesting way of breaking down type binding. Right, so we're talking about now when is a type bound to a variable. And it's possible that the type could be bound to the variable at language design time, compile time, link, load, run, whatever. But it's so common to have the type bound at compile time and at runtime. That's such a frequent thing that appears in languages that we actually have names for those types of binding. So it's called static versus dynamic binding. So with static binding, the attribute is bound at compile time, and the attribute can never change. So when I say attribute, I'm really talking about type. And in dynamic, it's bound, the type is bound at runtime, and it's possible, depending on the language, that the type can actually be rebound. So a variable can take on multiple types, depending on which language that you're working with. In addition, type binding can be explicit in which case you must declare the type of the variable. So an example of that would be something like this, double number. Okay, so that's an explicit type declaration. But it can also be implicit. And in this case, the name infers the type. So this is a little weird. So an example from Fortran 77. Fortran 77 example of this would be if I said, if I declare any variable that starts with I, like, this is cute, implicit. If I use that variable without declaring it anywhere in the Fortran code, then Fortran will expect that this is an integer. Now the way it does that is any variable that starts with I, J, K, L, M, or N is implicitly considered to be an integer. So you just have to start with this. Start your variable name. And it's an integer. And if you don't do that, if the variable doesn't start with one of those 6 letters, then it is implicitly considered a rational number, or in Fortran they're called real. So okay, so the type is real. All right, so starting with those letters I, J, K, L, M, and N, if you start any variable with that letter, it's implicitly considered by Fortran an integer. You don't have to declare the variable. You can just start using it, and Fortran will know, hey, it's an integer. If you don't declare a variable and you start the variable with anything other than I, J, K, L, M, and N, then Fortran 77 is going to consider the variable a rational type or real number. Here's some other examples of implicit. We have Perl. And in Perl, if you start a variable with a $, that means it's a scalar, which is a string or a number. If you start a variable with an @ symbol, then it's considered an array. If you start a variable with %, it's considered a hash structure. And so I'll give you an examples of this. All right. So if I say $apple, then apple is considered a scalar variable. It's either going to have a number in it or a string in it. If I say @apple, then I've basically said that apple is an array. And here's an example of me initializing apple to some elements: red, green, yellow. If I wanted to access an element in this array, what I would do is I would say something like this: print $apple 0. So here what I'm saying is I'm indexing the array apple, and I'm expecting a scalar to be produced from that index. And so I've set the print statement up to expect that. And what it'll do is it'll print out red if I do that. if I want to mess around with a hash, I can do this. I can say %apple equals, and then I'm going to set up since it's a hash, the way hashes work, hash is a structure that has a key and then a value, and so there's a key value pattern that you do when you initialize hashes. So I can say red is sweet, sweet, and green is tart, and yellow is juicy. Okay. And then if I wanted to access a particular key, access a particular value in the hash, what I would do is I would say print $apple. So I'm saying, hey, I've got a scalar, and do curly brace, and then say red. And it would use this key red, match it to here, and what I'd end up with is this value sweet. Now, I just want to say one thing about this. Actually, no. And you can use the same variable apple, the same name apple, in all of these instances, and Perl will infer which type of apple you're talking about. Are you talking about the scalar apple? Are you talking about the array apple? Are you talking about the hash apple? It's all in context with how you're using that name apple, and whether you precede it with the scalar or you an index with square brackets, whether you don't have proceed with scalar but you don't have anything after it, then it knows that you're talking about just this apple here, or whether you proceed it with a scalar and then you use these curly braces, in which case it knows you're talking about getting into the hash apple to get your answer. All right. So I've talked about explicit and implicit binding, and now I want to talk about dynamic binding. I've also, yeah, that's what I want to do. Okay, so I want to talk about dynamic binding next. All right. So, dynamic binding.